So I'm out on Blackboard here, and I'll open up the SOP for creating measurement plans, and it looks like we've already done the setup. In fact, the seed file that I opened up already had the setup done. It had the base alignment, had the clearance plane, and all that jazz. So we just did the Features tab. We probed the features. The strategies were set automatically because for points and circles, you can automate that under Resources and Save Load Defaults. We didn't even have to reorder it to optimize our cycle time because we selected the features in a path-efficient order to begin with, and create characteristics that is optional for direct characteristics only. Well, the whole point of this assignment is that there are no direct characteristics. So on our dimension report, we are now going to go to our dimension report, our characteristics tab, and we're going to create some characteristics. Then we'll go back and name them, set up the tolerances, and then reorder them to match the balloon numbers on the print. Now, if you want to combine some of these steps, go ahead, but I would advise not doing too many of them all at the same time, because then you probably will miss some things that'll end up taking longer overall. So we'll come into our characteristics tab, and we'll take a look at our dimension report here. And this one already has balloons on it. So let's say, let's say we just go in order of the balloons to begin with and see if that works. So the first balloon we have goes from step 1 to step 2, and it goes along the x-axis. Let's see if I can just right screen this. Let's see if that'll work. Will not work. All right, let's see if we can grab this whole window and do the left screen. Will that work? And then our stoplight, we can just move our stoplight out of the way here. We don't need our simulation window anymore. And that's much better. Now we can look at them back to back. We don't have to keep switching windows. So let's come up here to size, and it's not going to be in standards anymore. It's going to be under distance. And in this case, we just want a simple Cartesian distance. So that comes in as Cartesian distance 1 by default. We'll double click on it, and the first thing we'll do is rename it. So we have B1 underscore. And let's call this, what would help a person figure out what this is? Maybe it's a distance from step 1 to step 2. So step 1 to step 2. And then we'll put an underscore. And that is going to be along the x-axis. So in this case, our feature is going to be, we'll use our graphics window. If this pops up, you can just pull this out of the way. We'll use our graphics window to help us see what's what, because I don't remember which order these were measured in. So it looks like 0.3 and 0.5 are going to be what we want. So we'll click on 0.3, we'll click on 0.5 from the list, and to get into the list, I'm just pressing on this button right here. For our primary datum, we want that to be plane number 1. So if we were to take this measurement, which surface would we be holding the part against as the primary surface? And that would be our primary datum. And then we have a secondary datum. So if you just had this part up against an angle iron on a surface plate, it would be rotating any which way. So our secondary datum should just be datum B. That would be line number 1. All right, now we have parallel to and perpendicular to here. In this case, we want to be parallel to both. In all cases for measuring these, we want to be parallel to our primary datum. However, we may have to be parallel or perpendicular to the secondary datum, depending on whether we want to measure X or Y. Now, I said we don't want to chunk too many of these things at one time, but I guess I'm going to break my own rule here. My workflow on this is I like to, as long as I have this window open, I'll complete everything in this window so I don't have to open it again. So we're actually going to do all 4 of these steps, and we're going to move, we're going to do the first 3 steps, then we're going to move on to the next characteristic and do the next 3 steps again and again and again. All right, so here, this is defaulting to 393.7. That's because this model was created in metric. Is that close enough for our dimension report? The answer is no. If you're even a tenth off, you have to update this nominal value, and you have to go back and check your work afterwards as well. Right, so our tolerance for everything on this print is going to be plus or minus 5, so I'm not even going to mention it when I update the tolerances, but everything is plus or minus 5, so I will just update those automatically. So there we go. I hit OK, and our first balloon is done. So rather than going back to size and distance and Cartesian, which to me seems harder than it needs to be, I'll just highlight this on the screen and I'll do a Control C and then a Control V. Control C copies, Control V pastes. Then I'll double click and I'll start renaming this. So this is now going to be B2, and this is going to be step 1 to X overall. So that's my acronym I use for X overall. This is still going along the X axis. Notice that my nominal is 394 and my actual is 393.7. Well, when I change from point number 5 here, which is right here, to the overall of the part, which is point number 7, this actual updates automatically and the nominal becomes set automatically from the actual. Now again, this is only 1/10 off, but it's still incorrect if you don't update that nominal. The tolerances stay. So the first one took a while to do. After that, it's really just a matter of copy pasting, at least for this particular assignment. Now with the next one, we have a couple of things we got to watch out for. So we're now doing balloon number 3. That's 472 thousandths. It goes from our Y overall point to our step 2 point. So this is going to be B3. This is going to go from step 2 to our Y overall, and we're going to be measuring the Y-axis distance for that. So now point 3 has to switch, and point 3 wants to switch to whichever point we touch on this surface. So again, we'll use the graphics screen for that. Looks like it's point number 4 is the one that we want. And then we'll switch this over to whichever point is our Y overall. It looks like point 2 up here was our Y overall, based on the way I measured it. Right. And now we have to be careful here because it's telling us our distance is 1 inch 234. Well, that's coming from wherever that point is to wherever that point is along the x-axis, because we said parallel to our primary or our secondary datum. Well, our secondary datum goes along x, so parallel to x is going to be along x. That is not what we want. We want along the y-axis. So we'll switch this to perpendicular to. Now our actual comes in at 472.5. It's supposed to be 472. Don't forget to update that nominal. All right, so that was really the trick there. So we'll go through and do pretty much the same thing for the rest. So copy paste. This is now going to be balloon 4. This is going to be our step 2 to Y overall Y. Okay, so before I do anything here, I just realized I made a mistake. Balloon number 3 was actually step 1 to the Y overall. So I'll update that when I recognize that I made the mistake. This one is already named correctly, B4, step 2. I'm calling this step 2 over here. I'm calling this step 1 over here. And this should come in at about 709 thousandths when all is done. So it looks like in this case, we have to switch feature number 1 to 0.6, say OK. And notice that it gives us 708 thousandths and 7/10. Just update the nominal there. Tolerances stay the same. All right, now for dimension number 5. Same thing. That's along the y-axis, so we'll copy paste. We'll rename this, and now this isn't step 2 to y overall. This would be circle 1. So I'm naming these in my head circle 1, circle 2, and circle 3, just because that's the order that I did them in. You can call them whatever you want. You just want to make sure that it matches whatever you're doing in your blueprint and you follow some sort of system. So you don't call this circle 1 when you're doing the y and call this circle 1 when you're doing the x. That's all I really care about. All right, so we're doing circle 1 to y overall, and that's going to be along the y-axis. So our y overall is point number 2, so we will change the distance to circle 1. We are still going perpendicular. And we're 2 inch 576. We should be 2 inch 577. So we'll update that nominal and hit enter and OK. All right, next balloon. It looks like we're going to balloon number 6. So I'm going to grab something that already goes along the x-axis. So I'll grab balloon number 2 in this case. And I'll paste that down here. And the only reason I did that, I guess laziness, I already have this parallel to set, and I already have this 0.7 set for the x-axis surface, the x-axis overall. So that'll just make it a little easier. Now it's only one click to switch over to measuring circle 1. So we have balloon 6 is going to be circle 1 or hole 1, whatever you want to call it. I guess hole 1 would be a more accurate thing to call it. And that's distance from hole 1 to the x overall. That gives us 809 thousandths and 1/10. It should be 809 thousandths. So we'll hit OK and OK. And I just realized I made a mistake on the last one too. I should have called that hole 1. Again, whatever you do, make sure it's consistent. The next thing we need is balloon number 7. So it looks like balloon 6 is going to be very similar to that. I always start with the one that is the most similar that I can find. We'll rename it. We'll switch circle 1 to circle 2 and say OK. And our nominal is 2 inch, 110 and 2/10. We'll just update that. Say OK. Next balloon would be balloon number 8. So that's going to be something along the y-axis. So let's grab hole 1's y and put that here. This will go from B5 to B8. This is now going for hole 2. And this is going to be hole 2 to y overall along the y-axis. So we'll simply switch this from circle 1 to circle 2, hit OK. And then 2 inch 748.1 should be 2 inch 748. So we'll update that and hit OK. And we only have one left. That would be circle 3. So we'll copy balloon 8, change it to balloon 9. And this is going to be hole 3 to y overall along the y-axis. And we'll just switch circle 2 to circle 3. All right, our nominal comes in at 881.9. It should be 882. Now, there's a very good chance that I made a mistake when I was doing this. So I'm going to go back and run this. Now, what's interesting about this, I assumed I had to run it, but you notice that all these tolerances came in as green already in the characteristics list. You know what I'm going to do? I won't run that. I'll just come to here under View and go Multiple Report. So this way I don't have to wait for the simulation to run. Yeah, I'm just making sure my stoplight is green there. We'll go View and Multiple Report. Okay, and I guess it doesn't want to run. So we'll do something different. We'll go to our Run menu. And here, we won't clear our existing results. We're just going to measure all characteristics. We'll leave everything else alone. We'll hit Start. And notice that that runs through all the characteristics really quickly. And then it generates the report without even having to measure anything. Now, that doesn't really make a huge difference when you're in simulation because the simulation runs relatively quickly anyway. However, if you're on the machine and you just want to rerun a select list of features or just output a dimension report based on features you've already measured, that trick, the Clear Existing Results checkbox, can save you a lot of time rerunning your programs. All right, so let's come over here and systematically check that we've set all of our nominals and tolerances correctly and we've named all of our features appropriately. So for this, I'm going to try to go as systematic as possible. I'm going to review this row by row. So the first row is B1, step 1 to step 2. Okay, so that's B1. It does go from step 1 to step 2. It's doing it along the x-axis. My nominal value is 394, which it should be, and that is plus or minus 5. That's beautiful. Next, we have B2 is step 1. B2 is step 1 to x overall, yep. And it's measuring along the x-axis, that's good. The nominal is 630, plus or minus 5, beautiful. B3, step 1 to y overall. So B3 is going to be step 1 to y overall. Should be 472 nominal, plus or minus 5 is beautiful. B4 is step 2 to y overall. B4, step 2, y overall, should be 709. It is, it's beautiful. All right, B5, hole 1 to y overall. Yep, so hole 1, y overall is 2 inch 577, plus or minus 5. B6 is hole 1 to x overall along the x-axis, 809 plus or minus 5. B7, hole 2, yep. 2 inch, it's x overall along the x-axis is 2 inch 110 plus or minus 5. B8 is, where is B8? Okay, that should be hole 2 to x overall, or I'm sorry, y overall along the y-axis, 2 inch 748 plus or minus 5. And last but not least, B9 is whole 3 to y overall along the y-axis should be 882 plus or minus 5. All right, so there are no mistakes this time, but normally there are quite a few mistakes that I have to go back and fix, and that's part of the normal process. You always have to systematically review your work at the end. This is exactly what I'm going to do when I review your work. I'm going to scan down your nominal, your tolerances, make sure that they match. I'll look at your feature names, make sure that they make sense. And another thing that I'm looking at without mentioning it, I'm looking at these measured values and making sure that they're reasonably close to the nominal value. For instance, if I had 394 thousandths for my nominal value, but this measured value was 1 inch 268, well, it probably means you selected along the x-axis instead of along the y-axis or something like that, and that means the CMM is giving you misleading data. So that is really all we have to do for this. We will go in and save our dimension report. So we'll hit the File to PDF icon. We'll save this as the same name, same exact name as our file here. And this time I'd like you to put your dimension report inside of your file in a folder called Dimension Reports. And just hit Save. And what I'm realizing about doing it that way is now, when you go to submit this to me, you can just right-click on that folder and say Send to Compressed Zipped Folder. And if you look inside that folder has your dimension report right inside of it. So now you only have to submit one thing. So I'd like you to submit this one zip folder with your completed dimension report inside of it. All right, so that's it for this video. Thank you for watching. I'll see you at the next one.